course, is I'm going to get calculators because it's going to be way easy to actually get the answer. But these are in standard, this middle section, they'll do this easy version. So let's see if I do.
I'm scared.
First one I started by do 7. Second one, what exponent goes on the 2?
6.
So on the 2.
We got 6.
Oh, we got 6. We got 6.
6.
You shouldn't just. Yep, we got 6.
Come on.
Yeah, I told you I should have just left, but you guys wanted me to stay, so I was like, okay.
Well, we didn't. We told you to leave. That's
Oh.
what Eric told you too. He didn't want to. So Eric, don't show up. Just go do something.
You told me to go to class.
No, we didn't.
So you can see on each one of these. You can see on each one of these. As long as X is in the middle, automatically the two numbers are going to show up on the same side, and if they do, then it's just a matter of being able to put it in your calculator. That's why we're only doing 2 of these. What was the first one? It was a
343.
343, and the second one was
64.
64. Take a look at it. See for today. So right here. This is not where I have space. If you have over space in between, oh, you can write it above it. Mine doesn't have space above. The learning target is going to be, I can graph exponential functions. Basically, we're trying to get to the end of page 10 on there. Some of the pages are pretend pages. In other words, it looks like there's something there, but it's just a place for us to work out some of the stuff. Exponential functions. Can I squeeze it in? You can do it. You can do it. Write that in. So write down the learning target on that one. And for that one, Eric, you can put it above, because you're going to have space above, but not in between. And after you got one too, yeah? This handout here?
Yeah.
Okay. All right, so here's the first thing we do. Mess around with a thing called sequences. Let's see if I can get an extra space. Please write down the following numbers. Unfortunately, I'm going to write down the range. Write down the word range to remind you that the y side is the range. We're going to write down the range. And let's see if we can follow the sequence. So the 14, 21, 35. Your job is to find out what is it that they're doing to get from the first number to the second number, from the second number to the third. That will tell us what the sequence is.
They're adding 7.
From the first one to the second one.
Oh, never mind.
Yeah.
The first one to the second one to the...
I agree.
So you're going to write down kind of what I have here, and you're going to fill in the next 2 in the sequence calculator. I didn't get one F one. Again, you're either going to check see are they adding something, subtracting something, multiplying, or dividing something to the next number.
Oh, you're multiplying x times 7.
Yep.
I'm bad at sequences. I got them wrong on the SAT.
Again, once you write it in, figure out what they're doing to get from one to the next, and obviously you're going to fill in the last 2 in that. Officially, with sequence, it's numbers separated by commas. If you had a series, what would the difference be if this was a series? What would you see different? Anybody know? It's an easy answer if you know it. If what? If this were a series, what would you see different here? How would it be written to say this is a series? I know how it's written to say that it's a sequence, but I can write it to show that it's a series.
A bunch of unfortunate events.
Okay, that's one. I said that's a feel good. Here comes the series. You don't to write a series, the same numbers show up. This is just in case they put the vocabulary on a standardized test and say, please identify the series. Here's the difference. Instead of commas, you're going to have something else. You're going to have. You're going to have plus signs. Write that down. Write that down.
You lost one.
No, I'm going to be back.
That second line with the series is more if you get it on a standardized test and they say something with a series, at least you know there's a plus sign in there. Sequence, always separated by it. Two sides of the room, everyone gets to do one. The other side gets to do the other. Do you know what the next guy in line was?
I'm not very good at names.
77. And this side of the room, we'll use Samuel as backup, so don't answer Samuel. What was the one after 77 on this side of the room? Efren gave us the 77 and the 66. Yeah.
Plus 7.
Alright. So here's the deal. We're gonna graph this this and then begin the regular way. The question is this going to be a linear function or an exponential function?
A linear.
Who is talking about us?
And once we graph it, you'll see that. Go to the second page on yours. Mine will be the second page. You can use the table that they already gave you. But here's kind of one thing that I want you to do. I also want you to have in 0 and 1 as part of your tables. So say over here, they have mine, then they give me a table. If I were making a table, and I want you to throw a table in over here, even though they gave you one, let's see if I can get it up closer to where the function is. I'm gonna put mine up here so I can get it closer to that. Hopefully it doesn't mess you up. Oh, this is gonna mess things up. On the table, put in a 0 and a 1 before the 2's and so on. In other words, whenever you do a graph, you always want 0, you always want 1. That other table, I don't know why they began with a 2 and a 4 and so on.
I think they're just not to
Yeah. Now again, what they're showing you here is stuff that you've done before, but they're going to switch it in a minute. And when they switch it, that's when you're like, oh shoot. All right, so put in your table 2, 4, and then I'm going to stop at 5. You really don't need more than 5 to graph it. Once you get in your table, go ahead and put it in the graph. When you start putting in the graph, I'm going to come over and see. And again, the question like, well, how am I getting the answers? Where do I see an x? If I put in a 0, 0 times 7 is what, somebody?
0.
Yeah. And then, of course, you put in a 1, put in a 2. This is old school graphing, no big deal. We're going to give 7 a special name so that when they do it on the exponentials, you'll be like, oh, shoot. But all it means, this 7 is going to be called a growth rate. How fast are the numbers getting bigger? Growth rate. Now you're going to need that because they're going to use that word in exponential function. You'll be like, whoa, what's that? How fast is the number getting bigger? All right?
This one is skilled. So you gotta call me good doing this.
You did yours, Sammy, you said you scaled the y by what?
Usually 7.
They're not. The wind has in. School's pretty good.
You know, one time I took my eyelashes off and this is recording. Great story. This is my story. No,
That's how I pulled out.
Say something now.
There, it's recording now.
Come and check off as some of you are making an adjustment because maybe you put in the wrong numbers. Now the goal isn't this particular graphing. 7, 14.
Oh, no, you don't remember that.
You know you put your feet up right here. And then your page. Here's what I want. Please write down your range, please. Please write down your range as a sequence. I'm trying to use math vocabulary, so if someone ever said like that, you know, range, second half. Please write down the sequence. And we're going to try and figure out, you have calculated, you can try and figure out what the next two would be if you figure out what the pattern is from 3 to 9, 9 to 27. So step 1, please write down the sequence of the range.
I will burn your house down to do that in there.
Damn.
What the heck? Ew.
Is that a...
That
How did they get from 2 to... How did they get 2 to
I don't know how to do
This one might be a little trickier, but step 1, if you start by writing it down,
No, because he wants to
that. No, I said I did it on tic-tac-toe trouble accident. Like I meant to do like one line, but I ended up doing 2.
so what you do, you're going to try to figure out what did you need to do to get from 3 to 9,
Oh, it's
and then what do you need to do to get from 9 to 27. Once you didn't know those two, then the 81, the 243 become
you're
easier.
supposed
But
to-
you gotta figure out, okay, am I adding? Am I subtracting? These are your only choices. Am I adding, subtracting, multiplying, dividing? So once you choose one of those four, add, subtract, multiply, divide, then you'll get to see the pattern. I'm gonna write down my sequence.
Oh, I know the pattern. Yeah, because the next one that goes there is 3.
Whoa.
9 times 3.
Whoa.
7 times
Now, because you have a calculator, I do want you to get the next two if you figured out what the pattern was.
Yeah, I know.
Oh, they're doing it to each other? I thought you have to do something to the X to get Y.
Right, and that's why I'm saying only write down the sequence of the range. When you have the sequence of the
I
range,
get it.
now you can look and see, is there a pattern here?
I get it.
All right, I'm going to figure out what the pattern was.
Well,
All right, what was the pattern? What was the pattern to get to the next number? From 3 to get to 3 to 9?
Multiply by 3.
Yeah, you multiply by 3, 3 times 3 will get you to 9. If you multiply the 9 by 3, it'll get you to 27. And it's true if you check it in your calculators. To multiply the 3 times
Yeah, I
27.
finally understood one.
Here is the rule. This is exponential. How do you know exponential? To get to the next number, you have to multiply.
It's going.
Linear, you add, click, click, click. So write down exponential. Exponential, and then arrow, you must multiply. That's the big deal when I ask you, this is an exponential function. Your answer will be yes, because you must multiply.
Thomas,
Mm-hmm.
isn't there supposed to be an equation?
No.
You're supposed to-
Eventually, we're going to get the equation. But right now, I just wanted to see, hey, if I were given a group of numbers, and I need to try and check a pattern, you have to get from the first number to the second one, you have to multiply it, and so the second one to the third, you multiply the same exact number, then you know you have it. Which is going to take us to the next one. What was the next one in line? It was 729, is that what you guys had? And what was the guy right after him?
No, seriously? Why is that his
2,187?
multiple times?
Do me a favor, the 2 points I have there, see if you can write down the coordinates right next door to those 2 points. So on the graph that they have there for you, see if you can write down the coordinates next to the 2 points that they put for you, the 2 yellow dots on mine. Write down what it is. Is it? I know this is going to be 1,
It's going to be
2, 3. The question is, what is probably up there?
It's going to be 3.
This is where you're going to use that table that's on the other side. On the table, do they start at 0 or they start at 1?
Wait, which one? This side?
Do they start at 1 or 0?
1.
All right.
I don't. Can I come up and count it? Because
What was that?
Actually,
I don't know.
the input.
Please write down the answer to this question.
No.
Like, I'm
I went
volunteered.
back,
Hey, you volunteered.
If you
Yeah,
fucking get out for the concording.
Try to write it down here.
I wrote it down.
No, the answer to this question on the board, if you write down the answer, the one on the board, write that problem down. Write the problem down right here, and I'm gonna see what you write down for it.
I think I know.
It's a tricky question. I'm gonna show you why the answer is what it is. If you have to guess.
I don't know if mine's right, so I'm just.
Right there.
Jesus,
Write that
Tom.
down. 3 to the 0.
You can be a part of
What
it.
did he degree?
He didn't.
Sure. Go where there you go.
What was the answer to that one? It was. Somebody had it.
It was right, dude. I'm gonna get.
I'm going to show you why that is and why any number raised to the 0 power is 1.
Yeah, I know.
Please write down this pattern with me. Start the pattern right here. We're going to start with 3 to the,
Oh, what?
let's do 3 to the 4th power. We'll have somebody put that in the cut. Well, 3 to the 3rd power. That one's to the 4th is too high. 3 to the 3rd power. Somebody put that in the cut.
27.
27. No big deal. Write these down because you're going to see the pattern. We do it with 2s. I'm going to have you do it with 2s in just a second. So I'm going to do the 2 part. Just watch the pattern. 3 to the 2nd power. What's the answer on that one?
9.
Yeah, 9. No big deal. But notice something. To get from 27 down to the 9, if we just divide it by
3.
if we just divide it by 3, Come on. It would get us the next line down. All right, let's go down further. 3 to the 1 power. Someone say that answer.
3.
Sure. But also write that down. Write that down. 3 to the 1 power. It is. Oops, not a 1. Sorry.
And 3 to 0.
It is a 3. But watch this. The way you get down from the 9 to the 3, you divide by 3. So watch this next move. This is the one that gives you the reason. Watch this. 3 to the 0 power, power of 1, it equals 1, but the reason it equals 1 is to get from this line to the next line. To get smaller, you're always dividing by whatever the base is, and in this case, the base is 3. So when you divide 3 by 3, you will always get this 1. Let me do one more, which is a negative exponent, which might explain why it turns into not a negative number. Let's see what some people guess on this one. Right now, what do you think the answer would be for 3 to the negative 1 power? And my hint will be, look what we did to get to this line. Look what we did to get to this line.
3.
Look what we did to get to this line. What would you do to get down to the next line?
A decimal.
If you use a calculator, it'd be a decimal. We're not going to use a calculator for this one. All right, what you got there?
1/3.
It is going to be 1/3. That is, some students think a negative exponent turns the answer to a negative answer, but it doesn't. The next step to do, you get a 1/3. And the reason you get that 1/3 again is to get from this line to this one, you divide by 3. Do me a favor, do this little process, write it down with 2 to the 3rd power, and go down. The main two that are super important are this one here and this one here. Deal with the 2 so that you can see that you could do it.
That's all you do. You go to the.
Oh, I know him. He's the one who always wakes up Bella.
Yeah, that's right.
She was my twin.
Yeah.
He always. He.
I'm going to come around and check this one off. I know, Sam, I think you raised your hand already.
Play sports now.
They don't let you play sports.
Yeah, I think so.
Let's see. And then 21 they send you a note.
No negatives. The negative exponent can't produce a negative.
Oh, that's true.
Yeah, it'll never cross the line. All right, here we go. What you got on this one? FN, 2 to the 3rd.
8.
2 to the 2nd,
4.
Brenda. 2 to the 1st.
2.
And then our star, 2 to the 0.
1.
That's going to be important because whenever we graph an exponential function, 0, the coordinate 0, the partner will always be 1. It's going to be a picture that starts from the ground and goes up, but always, no matter what the base is, if it's a 2, if it's a 3, if it's a 10,000, doesn't matter. It has to go through the point 0, comma 1. Because what that means is when an exponent is 0, y has to be 1, which is what we're going to have on the next line when we're trying to draw a picture. All right, here we go. Let's see if we can, this was, what you say, Jose, what's your answer? Thank you. All right, here we go. All right, another pattern. Now this is kind of getting important because, yeah, as you know, they're not just going to give you like, oh, here's a number, write in a little pattern. No, it's going to be in a big paragraph. So what I want to do for you, what page is this on? 5. Okay, we're halfway there. I just want to read it so that you can start seeing how do they say the words and how does that turn into an equation. What will the equations look like? Back up for just a second because Eric had asked this kind of earlier. An exponential equation has to look like this where the x is in the exponent. If x is not in the exponent, it is not an exponential equation. As a matter of fact, no, I'll leave it like that. So this new equation, somehow I'm going to want it looking like this thing here. Let's see if we can make it do it. All right, here it comes. Hey, a tree frog population doubles. Please circle doubles. Oh, man. They can always say only doubles or triples. What number goes with doubles?
2.
Yeah. If they said triples, it'd be 3 quadruples, 4. They're not going to say quintuples, but it would be 5 if that's a real word. In any case, every month, underline every month, that part's going to be important. Eventually, they have to tell you what it does and how long it takes to do it. All right, next part. Suppose that currently there are 10 tree frogs. Zigzaggy on currently, that's important. How much you have now
7.
is going to be the important thing. As a matter of fact, that's going to be called the initial amount.
I was going to say that.
Oh, hey, what is that called when I say currently? Hey, initial amount, good job. All right, now here comes. How many tree frogs will there be in 6 months is the question, assuming that there are 4 weeks in each month. Here's what I want you to write down. I want you to write down this formula.
If not,
They're going to give it to us later, but I'm going to have you write down now. Let's see. Let me see how much space they have. Okay, you can write it below. Y equals A, that's the initial amount.
No quarters.
Initial amount
Nickels.
times B.
If I'm really
B is the base. That's the thing. Is it going to double? Is it going to triple? This is the growth rate. I'm right the growth rate, but I'm going to put doubles, triples under that. Growth rate, I have to put the official word because they're going to say, well, the growth rate is doubling every month. What is the equation? You're like, what? So you need to know the word growth rate. And some of the key words for growth rate will be doubles,
Okay, fine. I'll be nice and I'll throw leaves.
triples,
Little stems.
no, but not only one.
etc. And then the last part of this puzzle to the x power. Okay, write that down, write that down. There's only 2 parts you need to know. The y and the x, they come automatically. You don't have to do anything. You're always going to write y equals blank, 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 x. The only part you need to figure out is, hey, what's the a? What do we start off with? 10, 20, 30, 40?
50.
50?
60.
70? All right, got it. All right, there it goes. And then how is it growing? Is it doubling? Is it tripling? Is it getting smaller? Is it going up by 2%, 5%? That's the only 2 pieces you need. And A is easy, so really all you got to do is be smart to get 1 piece. And that is, what is the growth rate? All right, let's see if you can start writing out this equation, please. What are we going to put? I wish I didn't write that all there. Let's write the equation over here again, and we're going to actually put in the pieces to it. There it comes. Then hopefully there's another one right after that sounds like it that you can put in, like check off. I'll ask this out loud. Hey, somebody tell me what I'm putting in the place of A. What did it start with? I heard it. Say it again.
10.
Yeah. Start off with 10 frogs. The puzzle's almost halfway done. What is the growth rate? 2. So 2 is the base on this one. And then I just raise that 2 to the x. The x is always going to be time. Let's say, hey, what happened in 5 months? You put a 5 in the place of the x. Work it out, boom, you know the answer. This one's in 6 months, so to actually get the answer on this problem, I'm going to have us write the answer, the problem in one last time, but this time we're going to put in a 6 and we're going to stop there. Does he want you to get the answer right now? No. He wants you to be able to build it. All right, let's see if there's another one where they say words like these on the other page. We'll come back and fill in that chart on page 6. We'll go to page 7 and see if there's a story on page 7. If there is, try to identify the part. Read page 7, circle the things that are in the paragraph, and it's true, they actually just give you the equation that goes with it. But read it so that you can hear how they ask these questions for you to build it. And then eventually I'm going to see if we can go down to, I think it's page 11 to actually build one ourselves. Go ahead and read that for a second, and for recording purposes, as you look for the growth rate, highlight the number that's growth rate, put a GR next to it. If it for the initial amount, put an A next to the initial amount, and that way, when I see your papers, I know that the GR is the growth rate. All right, here it comes. Let's say that out loud. What's the word that tells me the growth rate? Or what's the initial amount? Yeah, starts with 30. And again, in this particular problem, they give us the formula, we were going to rewrite with a y. And then, did they say doubles or triples in this one? Yeah. And again, put a 2 next to that. This is the A, the initial amount, and the GR. So you put the GR next to growth rate.
Wait, you should more.
All right. I want us though to rewrite it. They wrote it with the f of x. Please write it next door with the y equals the 30 to the x. Please write that, and then below it, write it with the a, the b, and the x. Now I want you to just get used to the idea that as they give it to you, y equals the a times the b raised to the x. Now you can see in this particular problem, they're trying to figure out, oh, okay, what's going to happen in 56 days. This problem is a trick one. I don't want to even have you solve it, but because they talk about how many, after the number of weeks, a student who wasn't paying attention, they say, hey, what happened in 56 days? Well, time is always the x. So some student would probably just put a 56 in the place of the x, and then they'd work it out. But because they asked for weeks, you have to figure out how many weeks is 56 days. In other words, how many times does 7 go into 56? And then I'll tell you how many weeks you have. Right. Yeah, they did the whole thing for you. The thinking that you would need this as an example. But my goal here isn't, hey, do they know how to go from days to weeks? No. My goal is when you read it, you hear the word doubles or triples, and so you know it's going to be a 2. And then do they say, oh, you started out with 30, you started out with 20. And that's the first one. Let me see if I can find when, let's see if I can find, go to page 9. We're going to come back to 8 and get the answer, but go to page 9. Please mark it accordingly. Page 9.
I know who shot it, but I'm sure he's.
All right, now this one, double the triples.
Oh.
Right, and then just put it right there next to it. It's nice to do this evening test, but you got your A, you got your 2.
Don't tell me that.
You asked.
5 grand.
That's
2.
No.
Any questions on how to find these if it was on the test? Not how to get the answer, how to set it up, because they're always going to give you years somewhere. You plug that in,
So it's
you get
double?
the answer, no big deal. All right, how about a triple and see if it can mess with you, and then we'll go to page 15 and see if you can find whether it says doubles, triples, and see if you can write an equation. This one's a little trickier. Okay, so let's see if we can get around this one together. Did anyone guess what the A might be?
360.
Yeah. Because this question is about money, eventually, the 360 is going to be the money. Usually, the year they give it to you is just to kind of get you started. So put an A for that 360. What was the B again?
7.
Yeah. The B, and this is the kind they like for the test. The kind with percents. They like to do that because there's a certain thing we have to do for the B. Now, you wouldn't know what it is just yet. We'll fix it, but for now, if the A is a 360, and the B is that 7%, which usually they write as a decimal.
Oh, 0.7?
Or 0.07. I'll write the 7%, and then I'll put it here as a decimal, 0.07, which is the way they like to write it. Now the question is, can I put those into the equation? Again, if you're writing in pen, something's going to change, but I'm going to let you put it in that we identified the 2. So the hardest part is, okay, which is which? But once you have it, ABX, why ABX? If you know to ask that question, then I'll automatically tell you the order to write it in as well. And so what am I writing for the A again? 360, that one wins. I'm going to put that in parentheses so I can multiply. What am I writing for the B?
7.7.
Oh, let me not-
0.07.
Yeah, and let me not put that in parentheses. You put the 360 just as is. The second one I'd like to put in parentheses on the test.
Oh.
0.07. What power? What am I going to raise that to?
Wait, double.
Or what am I putting on the 07? X. Yeah. The y and the x, they stay the same as far as the equation is concerned. Once they say what happened in the 5th year, then you put a 5 in place of the x, and then you punch into your calculator. What happened in the 10th year? Then you punch it in. All right, so here's the deal. Here's the part you need to know. I apologize for this. Whenever it's a percent and it's growing, you have to put a 1 in front of that. In other words, you have to do 0.07 plus 1. I hate this part here because it's tricky for some people. If they say it's decaying, it's smaller, it'd be 1 minus the percent. So for now, my main thing was, okay, can they find these two? But when it gets to the real deal, yes, the 360, that's regular. The growth factor, once you put it into the equation, you either have to do 1 plus 7 cents, which is $1.07, or you have to do 1 minus 7 cents, which would be like 93 cents. All right, pause. Go to page, go to page 8, please. Page 8, use your calculator. Punch those in, and you can fill in that answer. Page 8, what are you doing in the place of x? You're just going to put in, this is how they would ask the question. So go ahead and put those in. This one right here, you probably want to use parentheses. I don't know if you're going to use parentheses on the 5. So these are just so we can have pages 1 through 10 filled in. This is a little bit less, this is a little lower level than the test would ask you. You're definitely going to need a calculator on the second one.
Plug that text.
What page it was?
8.
So here on page 8, this one is obvious. You can do it in your head. Obviously, 6 to the second power, no big deal. This guy here on the test, when you get these, you just got to be able to plug it in. 20 parentheses, which is 20 times 0.5.
Actually, how'd you get the 4 equals 20? Oh, wait, never mind. I didn't see that.
And let me change that by y. Sorry about that. Alright, this I'm going to come around and check my. When you're graphing, like Sammy said, you'll scale it with whatever the base is. The base of the 4 would be 4, 8, 16. If the base was 7, like you did before, 7, 20, 14, 21. Go to the 4, the one with the 10, and go from there. 6 squared, someone?
36.
36, very nice. Alright. 20 times 0.5 raised to the 3rd power.
Isn't it 1.5?
You know what? It would normally be,
20 times
but just because they offered this one, boom, as is.
Raised to what power?
And I'll take that answer too.
Raised
To the 3rd power. So, as is the answer for this one, just because it's just a regular part that's written. But if it was in a paragraph,
It was
and
in
it said,
percentage form?
and it said, oh, the rate is 0.5, then yeah, you're right. It'd be 1. Sorry about that, man. All right, anybody have an answer for it though? You say 0.5. 2.5? You got a 2.5 also? Anybody get anything different than that one? Make sure you punch it in to be able to get it.
I did. I put 20.
20 parentheses 0.5.
Wait, what was it? What was it again? 20 times.
If you have an exponential function, one thing I want you to know is if you have to choose numbers for the x's, please put down your x and your y. Always start with maybe to the 3rd power. In other words, choose x to be a 3, because it's going to be 4 to the 3rd power. Choose a 2, 1, 0, and just like we did, you can do that negative 1. Now, what are you going to notice with these? This is that same thing we just wrote a second ago with the 3s and the 2s. In other words, this is going to be 4 to the 3rd. That's going to be the answer to the first line. 4 to the 2nd.
Now what page is that?
To the 2nd. So this line here that has all the x's in it, really, because of the equation, it's the same little thing that you wrote just a few moments ago, which is why I was asking everybody to make sure you write it down. Some people wrote down just the final answer, but it's the pattern that I want you to have, so that if you have to do one of these charts, you know when I say X, I'm putting an X right up here into that power slot. A 3, a 2, a 1. And I also want you to go down 3, 2, 1. Normally, when you put in here, you put 0, 1, 2, 3.
I think I found that asymptote.
Yeah, and that's the other thing I'm going to mention with these, which they're going to ask about on your test. So right now, you're at medium test level. Not full, but these bigger. This time we start with we'll start with Jeremy because he didn't get it last time. Jeremy, yours is going to be 4 to the third power. Don't say yet. Jose will be 4 to the second. Sam 4 to the 1. Eric 4 to the 0. And then Brenda 4 to the negative 1. Remember, a negative exponent will never give you a negative power. Remember that negative answer. And that's why that asymptote, which Jose mentioned, asymptote is going to take us a line that these guys are not going to cross. That line is going to be actually x equals 0, you see what I mean? All right, let's see if I can get them this picture. Next class, we'll look at some more of these pictures because it's important. There we go. Let's get some answers. Here we go. 4 to the third, Jeremy. 64. 4 to the second, Jose.
What?
4 to the second. 4 to the 1, Samuel. 4 to the 0, he gets the star problem. The star, that one's super important. 1 it is. And then 4 to the negative 1.
Huh? 1/4, right?
125. Because you can't graph 1/4.
And we may not even have to, but
you gotta graph it, so.
So it's 0.25.
Well, you gotta graph it.
I'll keep that there for now, and they can. All right. So here's the deal. Remember when you scale this guy, the domain, the x's. Oh, regular 1, 2, 3, 4. You got your 0 and your negative 1. Those are fine. The y's or the ranges, whatever the base is, then use that. Now here's the deal. On these, mainly you're going to be kind of graphing the first 3 middle guys. You're not getting up to really 61 unless you need to. The first 3 is kind of what you need to get the picture. And the 3 middle guys is 0, star, important. The 1, easy. The 2 usually gets too big. The 3, you can forget about it. So on this one, if I'm actually scaling it, doing what is it? 4, 8, 16, 20. I'll stop there. Write that in. It's super small, I know. I'm going to come and check it on yours. And then I'm going to show you the most important part of drawing this picture. Any exponential, the most important part. Here it comes. So 0 and a 1. Oh, shoot. Hold
The door.
There's a problem. And it's the most important part of the thing, so we have to fix what's broken. It was true that if you scale it 4, 8, 16, the dots will fit better on there. But the problem is, since this line here is so important, we need a 1 on the y-axis. That part has to be there. Because 1 would be like right there. So here's what I'm going to say. And I hate that I got to do this.
Everyone at home, don't put in the effort.
We have to scale the y 1, 2, 3.
Okay, I'm just gonna.
I know. 1, 2, 3, 4. Sorry about that. Y's is so important.
I don't know
When they show the pictures of an exponential graph, they will always have this dot at 0, 1. He's like the most important part of the whole thing. And then of course it was 1, 4. Oh man, I apologize to you.
Yeah, apologize to them too.
I apologize to you too. All right, so here it comes out. Here's what the picture looks like though. The picture will always start like this on an exponential function. It'll start like an airplane on the runway. It'll come forward and it'll take off. It always takes off through that point there.
Well, that's what you said. But you just gotta put it in.
Write what you just saw. This part is the most important part. This kid just drew. If you do 0, 1, we'll see this again. If you do nothing else today, that is the main thing you want to do. All right.
Oh, yeah. My bad.
Sorry, last thing we do is get the picture that has a 10 on it, and then that'll be it. That was
Yeah, shut up.
Oh, okay. Asymptote.
1.
The asymptote is this black line here, the x-axis. It's never going below that, so here's how you write it.
It's like, no, I didn't miss it.
The asymptote is going to be x equals 0. Sorry, y equals 0. Sorry.
No, it turned me on like that.
Y
That's
equals
unbelievable.
Yeah, that was.
That's
Ah,
like,
that was weird. I feel like.
yeah, that's like, I'll
Yeah, I'm not sick.
I'm sitting there.
Why
Right
is
now-
it 0? I thought it's supposed to
No,
be
no,
the X.
Right.
God.
The official name of the x-axis is y equals 0. Because here, like,
Oh,
y is
yeah.
Okay, y equals 1 because that's where the line is.
The asymptote is the line, this green one is approaching, but it will never touch. The line that this green is approaching is this x-axis, and we'll say it again more than once. But for the asymptote, which again is not a big deal for me today, the big deal for me today is no, the pitch will always go through this, and this is an exponential function. We'll do it again next time for all of you who weren't here. Go to that page that has a 10 on it. Let's fill that in real fast so that we'll have that.